pleased to present our research work answered toward intelligent visualization of medical data, integration of the K-means clustering algorithm into an interactive dashboard. The study was carried out within the Laboratory of Mathematical Modeling and Economic Calculation at the Faculty of Economics and Management, Hassan First University of Stat. The presentation has been prepared by Fatima Zahra Razawi, Narjis Ouris, Fatima Zahra Qasimi, and Hussein bin Brahim. Our presentation is organized into 6 main parts. 1. Introduction, where we highlight the context and motivation of our work. 2. Research problem. 3. Research methodology. 4. Main results. 5. Recommendations and conclusion. Let us now begin with the introduction. All files we are currently facing an explosion of data volume. The situation creates an increasing difficulty for decision makers possible to effectively exploit and analyze this information. At the same time, we can observe the limits of traditional visualization since they are often static and descriptive, which makes them insufficient for complex analysis. Therefore, there is a strong need for tools capable of detecting complex patterns and risk profiles. The answer lies in the strategic integration of artificial intelligence into data visualization, leading us towards intelligent and interactive dashboards that truly support decision making. The research problem. Our central question was, how can artificial intelligence enhance data visualization in order to make it more interactive, more intelligent, and better tailored to needs of users? More specifically, we seek to understand how AI techniques can be integrated into the process of data visualization, and what benefits these techniques bring in terms of improving data understanding and supporting medical decision making. Our research methodology was divided into 2 complementary phases, a theoretical phase and a practical phase. Theoretical phase was based on a documentary study and conceptual framing. We structured our study into 2 parts. First, we explored the general concepts and foundations of intelligent data visualization, including AI techniques and the principles of intelligent business. Intelligent data visualization in the field of health. Strategic results in health. It makes complex medical data clear and accessible for caregivers. Help with diagnosis. Personalized patient follow-up. Hospital management and crisis. Practical phase consisted of the experiment and design of a smart dashboard. Functional objective design and intuitive visualization of patient profiles. Facilitate data exploration according to clinical variables, age, recurrent, etc. Allow dynamic filtering and targeted analysis. The use case. Provide an attractive tool for healthcare professionals. The preparation and pre-processing of data. Cleaning and encoding of categorical variables such as sex, smoking status, etc. Standardization or normalization to answer the consistency of the data used. Creation of measures and counts. Measures shows as recidivism rate, age group, comorbidity score. The dashboard pages 1 and 2 view displays the demographic and clinical characteristics of patients before modeling. And finally, modeling by the cluster model the K-means algorithm. The following graph shows this curves an intra-cluster inertia to determine the optimal number of clusters. We use elbow method to test several values of K to identify the optimal number of clusters. I=3. The lowest score used as a quality criterion at a separation of funny growth equal to 0.7. This volume equal to 1.3, which confirms correct internal coherence. On the main results obtained from the intelligent dashboard, let us now look at age cluster in detail. Cluster 1 includes mostly older patients, 16 years and above, with a recurrent rate of around 55%. They show high comorbidities, frequent tumor multifocality, and bilateral lymphadenopathy. This cluster represents a moderate risk profile that requires enhanced monitoring. Cluster 2 is characterized by the highest recurrence rate, about 86%. It includes patients of all ages, even those under 13, which reflects an aggressive clinical profile. The group presents tumor pontificality and complete response and frequent metastasis, even those comorbidities remain low. This is a priority cluster for clinical follow-up. Cluster 3 shows a very low recurrence rate, around 3%. Patients are mainly in early stages with no major comorbidities, no metastasis, and small tumors. They are mostly no-smokers and age-weight with favorable treatment outcomes. This cluster corresponds to a low-risk profile, requiring only standard monitoring. From these results, we move on to recommendations and future improvements. 1. Explore other clustering techniques. Use key medials or hierarchical clustering to compare the quality and coherence of patient profiles. 2. Integrate a supervised prediction model like a logistic regression or decision trees to predict recurrence risk and validate clusters with explainable predictions. 3. Implement adaptive clustering. Develop a model that automatically reduces grouping with the new data, useful for real-time systems. To conclude, let's summarize the main contributions of this work. The study shows that an intelligent dashboard helps doctors make better decisions. It lets them explore patients by groups and health factors, use filters like age or disease stage, and understand AI results easily. Even without technical skills, they show how AI can make data easy to use and helpful for decision making. Thank you for your attention.